All right, here we go. All right, guys, so before we will go to our presentation, let's go over our board. So I did review a couple of homework of the exercises that you guys submitted. Most of them seemed fine to me, as I have only two things to mention. That the first one is so basically, once you will open your account in GitLab, just make sure it has public access. Otherwise, like, I won't be able to review it, and your teammates won't be able to review it as well. So keep it in mind and make it public for now. And once we will work in one project for Selenium, we will have like one private repository. Other thing is, if someone doing code review for your work, just please leave a comment like code review passed or something, so we can like identify that this exercise was actually reviewed by someone before it came to ready for UAT. And the other small thing is that if you guys using like if-else blocks or any kind of loops, like I know you don't have to specify the brackets, like if you just one-line code, but please still do that because it's a best practice, and it's just like a standard to use like a brackets. And I mean, if you want to use them like in real work, most probably people will complain in a code review that you missed it. So yeah, keep it in mind.
Okay.
Do you guys, I mean, yeah, it was a common thing. It's not like only one person. I just noticed that. All right, do you guys have any questions about homework? Is it still clear for you?
Azat, I have a quick question.
Okay, go ahead.
Yeah. My question is about what is the best way to communicate with you? Because I asked a question in general Slack twice today and nobody replied me. And I spent half of a day to solve some simple problem. Eventually, I solved it by myself, but I wasted time. What's the best way to do it? Because when I asked you in private channel, you replied me way faster. So it's my question.
Yeah, the thing is, because I usually work during the day, and sometimes like I don't see all the notifications that came from a Slack, but I try to reply to it like as soon as I can. And yeah, I will probably maybe like ask Dennis to help me sometimes, like if you will know something. But we will try to reply as soon as we can. But why I asked to post in a general channel, because if like someone else will have the same problem and someone will help him, you will guys like just all know that what the solution is. But like you can always you know, like DM me, like send me like a private Slack message and ask me directly.
So it's a better way to ask in general, but if nobody replies, I can go to private, right?
Yeah, you can actually ping me. You can like if you ask in a general, like nobody replied to you, can ping me in a DM like, hey, like, can you take a look to my problem in a general channel? Yeah, and I will do that.
Okay, I got it. Thank you.
All right. Any other questions, guys, or concerns? Like, you're not blocked, right? I hadn't had a chance to participate in the stand-ups lately, so I just want to make sure like everything makes sense to you and everything's clear. All right, I will take it as a no, and we can start our presentation for today. Okay, just a small reminder that on Tuesday, we started to review OOP in Java, object-oriented programming concepts. So like we all, I hope, know what the class stands for and what the methods inside the class stands for. So we already should know what the like instance method is and what the static methods and what's the difference between them. So you should be like familiar with a constructor, and yeah, and also I posted some exercises for a first part of this presentation. We can review them again today if we'll have time. But before that, we actually gonna cover some of the topics that actually left here. It's inheritance, encapsulation, polymorphism, and abstraction. That's actually 4 base topics in the OOP. So basically, like all OOP stands for these 4 topics. Okay, let me hit the present mode and we can start. So yeah, so today we're basically gonna cover these 4 things. And in the end, we're gonna do like small exercises. Hopefully, like you will have time and just to make it easier for you to understand how it all works in Java. So they're simple. I don't think there should be like any problems for you to resolve it. All right, so the first thing is it's inheritance. So what the inheritance stands for, right? So basically it is what it's saying here. It is the way when we can basically, like you see this scheme right here, right? So as you can see here, it has like one kind of like parent element. It's called vehicle. And these 2 other ones, like car and boat, they kind of inherited from the vehicle. And because like car and boat, they both like vehicle, but it's more like more specified other instances, like one for a car and second one for a boat. And as you can see, you can also create more specified classes. Like for a car, it may be like sports car, trucks, like states, or like vans, or I don't know, like sedans or coupes, or like basically like any kind of car. The same for a boat. You can also specify like a sailing boat, like motor boat, cargo ship, or like anything like that. So the main idea is, let's say you can create a class and call it a base class, right? And even though like a car and a boat, they kind of like a different kind of vehicles, but both of them have a, like, let's say, have an engine, right? And so we can like reuse this like engine right there. Or like for cars, let's say in this example, to be like more specific, like all the cars, like sports cars, trucks, or like, I don't know, like SUVs, they all have 4 wheels. They all like have a, you know, like a passenger seats or like anything. So basically, instead of like specifying all these parameters, like in a sports car class, you can basically reuse most of these like methods or like elements that were specified in a car and use it within your like a new class. So here's the 2 things. You need to understand like superclass, it's basically the parent class. So in this case, it's a vehicle for a car and boat. And for like 3rd layer here, it's basically like a car and a vehicle. Like it's basically all the parent classes. And the subclass, it's basically all this like a child classes within that. All right, so just let me show you this small like code snippet. So basically the same idea, right? We have a class vehicle and we have a brand specified here, and we also have a method like action. It's called like honk, and in this case, it's using like a really simple like standard honk title. And in the below of that, you can see we have a new class. It's called the car, and it's actually extends from the vehicle. Extends, it's a keyword to have to inherit element. Like if you see like extends, that's mean like the car actually inherited from the vehicle. And in this case, vehicle will be a superclass, and the car will be a subclass for it. And so in the code below, you can see it's actually initiating a new car method here, and it's using the honk method, but it's basically not specified in a car class itself. It's specified in a vehicle, in a parent class. And that said that we can basically use all these methods or like attributes from the parent class. Does it make sense, guys? All right, let me probably show you like in a real example how it's looks like. So let's say again we have a testing. I mean, just for a demo class, it's called car. It's pretty much like the same as we used like in the last session, but I just like removed everything that we did there. And let's say let's create another class here. And let's name it, I don't know, like, let's call it Mercedes. Let's add it here. And so for now, I believe we can like leave it empty. And oh, so I forgot to specify its extend from the car. Extend the car.
Azad, can you please zoom up your code a little bit?
Oh yeah, let me actually do that.
Control plus maybe. Oh yeah, presentation, not even better.
Yeah.
Thank you.
Yeah, it's better, but I'm not sure how can I now switch to all the tabs. Okay, let me exit it for really quick.
Yeah, try to just control scroll maybe, control plus something.
Control plus. Control plus.
No, no luck.
No.
Yeah, there is an option for sure. Maybe it's the wrong shortcut, but
Command plus for MacBook.
oh yeah, right.
That's actually I'm trying to play press Command plus. Yeah, sorry guys. Yeah, is it like that bad? Like, can you guys like at least see it for now? All right, let me do that. I will just switch between the presentation mode back. So basically, right now we have a car class, right? And this is a super class, and we have a child class. It's called Mercedes, and it's inherent from the car class. And this is like an empty method completely. And if I go here to the main one. All right. So what we can do, we can initiate the Mercedes class, right? Let's do that. Let's call it MERC equal to the new class, which is Mercedes. And you guys remember it was an empty class, right? But it's actually inherited from the cars, which has like one method. And we can try to call this method. It's actually called print me. Yeah, and let's try to run it and see if we can do that. All right, so it basically printed me this demo TY thing. Okay, does it make sense, guys, for you? That I actually used this like method from the car class inside the Mercedes because it's inherited from it, and basically all the methods and all the attributes from the parent class, they are reusable in the child classes as well.
Guys, yeah, this is very important concept. You will see it everywhere in any programming languages, in and literally anywhere.
Yep.
It may seem to be a little kind of trickier, but it's not that bad actually. So it's called is type of relationship. So in this case, you can say that Mercedes is a car, right? So those both two classes are kind of equal. So that's why you can actually call the parent one. So it's convenient when you have like a whole bunch of different, let's say you want to create a whole bunch of cars, and then you know that like all those cars are really cars, so they should have some like engine, they can do the same thing, they can drive, right? They can fit maybe different number of people, which is gonna be another concept, but that we'll talk about later. But Mercedes is a car, Toyota is a car, like all those, whatever you need to create, they are all cars. So they have something in common, right? Is it clear, guys?
Yes.
Pretty clear.
It's clear so far.
Yeah. I mean, this is like a really simplified version. In real life, you will have classes like with like a lot of methods, like that's like 10 methods or like 5 methods, and you don't want to duplicate your code and use basically the same methods in another class, because the whole idea of programming language is just to avoid duplicated code. And instead of like specifying it again and copy paste, like you can just like use a inheritance and use it like within the child class. I mean, also to mention, like it's you need to be like very careful kind of with like inheritance, because once you will have like more data, like more kind of like a methods in a class, you can be like get confused and by that, and you may face like some kind of like problems because you won't notice that before.
Yeah, so one more remark here. So in this example can be kind of little abstracted, but in test automation, what we usually do, we create some kind of base page where we store like all the page related methods. Let's say navigate to that page, check if it's that page or not, and then we can inherit that page, and then we can create. But base page is kind of not real page, it's just something that is in common. But then the actual pages that we will be creating, like login page, home page, I mean any other pages basically, it doesn't matter, they will all inherit from base page. So they will get those methods from the base page because they are all pages, right? That's why.
Yeah, exactly. And the other thing to mention is that it's like we're gonna use all these OOP methods once you will start to work with our automation framework, because like like this like page object model, it basically has all these, just like 3 major parts of OOP. So you will see it in real example in real project.
Yeah, so the whole idea here is not just give you some random knowledge, but this is actually going to be used in our framework and pretty much in any framework that you will be working in, either existing or the ones you will build from scratch. In your company, you will see all of these things related to the test automation itself. But for now, we just stick to some basic examples like cars. Just you can understand what it is.
Yeah, we will reference probably a lot to this topic and to this class, and like
can you go back to the previous page?
To the previous.
Yeah, what is what is protected? You see,
Yeah, that's actually what I'm going to talk right now. It's called encapsulation. Yeah. So the thing is here, like, what's the encapsulation, right? Do you guys remember in our previous session we had methods, and we called them private and public. And for a private methods, we weren't able to use in a main function, right? So we had to set them public. This thing is called encapsulation. In encapsulation, that's basically kind of the way how you pretty much hiding some like kind of like sensitive data as it's specified here. So why do you need like to hide your like methods or your code? So it basically just to make your code more readable. Like, let's say if you have some methods, right, and you know for sure that you're not gonna reuse them, like outside of a class, it's better to keep them private. And like private means that you cannot reuse your code outside of the class. If you want to like reuse it, like if you know for sure that you're gonna like reuse it in any other like classes, or maybe like in a child classes or like anywhere else, you can use a private type for methods and for attributes. And let me actually check something.
Yeah, and I would add something here as well. So basically, actually, by default, it should be always private. So unless you want to expose those methods, you should be aware of that. But by default, it should be all private. So you don't want to really show what something that is not needed. But again, it's totally up to you to decide.
Yep. So we have three type of access in encapsulation. So the first one is a public, and as I mentioned, public attributes and public methods you can like reuse basically like anywhere you want. You like all you will need to do just you know like import the class or just like have class in the same package, and you will be able to reuse them. So private ones, like as I mentioned, it's only usable within the class, but not outside of that. And here's a third type of that. It's called protected. And answering to your question, Sergey, so protected means that you can use this method in a subclasses. Like let's go back here, right? So we have a Mercedes class, which actually inherited from the car, right? And this is a print me method. It's a public one, but we can change type to protected. And because it's a protected, I can still use it within this like a child class, which is a Mercedes. And I hope if like, let me actually change the text here. And if I will run it again, yeah, you guys see there's like no errors. It's like it's still printing it. But for protected, you cannot use it like outside of your like inheriting like branches. Like you cannot use it in a separate class unless it has a relationship with like a parent class. Does it make sense, guys?
Yeah. So this thing works with inheritance actually, right? So that's the actual use of inheritance, again, another concept.
Yeah, so this is basically, you're kind of still restricting your methods and data, but you're allowing it to, like, let's say, reuse for your child classes.
And the main class, right?
Yeah, the main class.
So if we will create, we already have car class, so if we will create ship class, for example, In this class, we will not be able to use car class methods, right?
Yeah, that's correct.
Okay.
I mean, if it has a private methods or like protected methods, and it won't be able to reuse it.
Okay.
So yeah, if you change this print me right now to private, it will go red, right?
But still, I can get the purpose of such approach. What is it for? For safety? For I don't know.
Yeah, basically you just want to hide away those details because usually what happens, like once you start writing your methods, then there is tons of them, and sometimes those methods are for kind of service purposes, so they really should reside within the class, but not to be exposed to the outside classes. You see, it turned red now, so it's saying like, hey, you know what? You cannot use it because it's private.
Yeah, so this is like a small classes, but let's open the string class. And this is like a really huge class, right? And
which is existing class, guys. It's kind of original Java core class, like the very basic one that we pretty much start with. So as you can see, how many classes are here, and how many methods are here, and how many lines of code.
Yeah, like in this case, like if you like just go over all these methods, you can like simply see, okay, this is a public method. That means that's probably this string method. It's kind of, you can use it like somewhere like, I mean, it's a constructor.
Oh, this is constructor, yeah.
Constructor, but let's say, okay, this one like a range check, you know, it's a private, right? And you know, like you cannot use it like, it's not supposed to be used outside of this class. And you just make it simple from the code reading and understanding perspective. Because like you guys not working with your code alone, you'll probably have like colleagues, other like developers or other like QA automation engineers. So
this actually, wow, that one is pretty big. It's just the beginning, but it's already 600 lines.
Yeah.
So yeah, as you can see, this one is massive. But another, wow, 3,400 almost. Oh, that's a lot. Another thing you can notice, a lot of green text. So I would say the first source of truth for you, if you don't know something, if you're curious to see like what's in there, how you can work with this class, you can actually jump here to the class itself, and that's usually how I do it. Especially, well, not all of the classes provide that much of information, even how to use it, but basically you don't even have to Google. Sometimes you just jump to the class and read like those methods that kind of make sense to you right now and try to understand.
Yeah, I mean, it's an example of a good written code, like where like for every basically string, it has like a lot of comments explaining what this like method actually is doing. But like in reality, you will see that like not everyone's maintains their code like that. Sometimes you just see like a bunch of like methods and functions, and you don't really know what they're doing. So, yeah. All right.
Well, and the another purpose of these comments, they actually getting printed in IDE itself. When you mouse over on the method, there is like a pop-up or tooltip showing like how this method is supposed to work. Well, at least it works. Works pretty well in the older Eclipse IDE. But when it comes to IntelliJ IDEA, I believe you need to change some settings in order to see those things.
Yeah, that's interesting. All right, guys. Do you have any other questions about encapsulation?
No.
Okay. All right, and here is so because like let me actually write something here before we'll continue. So let's say in a car we will have like a private attribute. Let's say I don't know, like wheels, right? Private integer wheels, right? And so we cannot like access it like outside of the class, but there's actually a method, like there's a few things how you can do that. You can use like a getters and setters in a Java. So basically what the getter and setter means, right? It's a methods within the class which basically allows you to interact with this private data. Like let's say, because we have a wheels attribute and it's a private, right? If we want to set this value for the wheels, we will need to specify the public method. Okay, because it's a set. Set wheels. Let's say it takes a string as an argument. Just call it wheels. And okay, let me change it so we won't be confused. Let's say, and this like set method, it will like set how much wheels have this car. Let's say we will need to specify this attribute equaling to and here's something that
usually how it works, well, first of all, yeah, it's an integer, not a string, right?
Oh yeah.
And then usually, in most cases, this parameter that comes to the method, it will be named wheels as well, like with the same name. Can you do that? Is that for me?
To do what sort of things?
Wheels, exactly the same name.
You mean instead of wheels?
Mm-hmm. Yeah. So now you see, well, okay. Now you see it's kind of confused probably because we have these two wheels now, which is within the scope of the method. It thinks that wheels equal wheels, which is obviously, I mean, whatever got there is equal to whatever got there, right? So it kind of, but do you see the wheels, which is private integer, it's still gray, so there is no use. So to avoid that confusion, you can actually separate out the wheels on top, which is line 5, and the wheels on line 7. And for that, there is a special keyword called this. So when you say this, it actually means the one on top. You see now it become purple. So that's how you separate out. And you can see this thing a lot, like everywhere, when like reading some other people code or some other libraries will say this wheels equal wheels. So as you can see, wheels purple. Now you can actually know exactly which is purple. That means these are the same variables, and white is white, right? You getting the point?
Yeah, and I believe like like in Java it will still work, even like if you won't specify it. But let's say in other programming languages, let's say in Python, there's like a similar keyword. It's called the self, and basically like if you won't specify the self, like it won't allow you to do that. So you have to like you kind of like forced to specify it. All right, so this is a setter where we can like set how many wheels car has, and this is a getter, right? So but both of them are public because we're gonna use them outside of the class. But the wheels attribute itself, it's a private. All right, so let's go to the main class.
So yeah, it's called backup field, and who can tell me why do we even need like this field and then get wheels and set wheels? Why it's so complicated? Why wouldn't you just set it directly to the wheels? Any guess? No? Okay. So basically the idea here is to prevent any other classes accessing this field directly for whatever reason. Why? Because you may want to actually have some other logic. Let's say once you set wheels, you may want to print it or log it to somewhere, not just set it. Or sometimes if it would be like a sum, for example, you can actually do some math operations as well, right? So that's why it's kind of all, it should be, the field should be private, but these setters and getters should be public. Is it clear, guys?
Yeah, let me actually show you in an example how it will be, how will we actually access that. So let's initiate back to the class method. Let's call it track, right? And this is a new car. And so let's say if we want, like, how many wheels tracks usually have? Like, I mean, it's obviously like 4 wheels, but like more heavy tracks, they may have like 2 additional wheels, right? So it will be like a 6-wheel car track. And let's set it. Let's say like track, set wheels, and the integer will be 6. And let's try to print out how many actually wheels it has right now. System out, print. And to get this information, again, we cannot use the wheels because it's a private. So we will need to use a get wheels method.
It's typo there.
Yes. All right. Let's print it. Yeah, it's 6 wheels track. Does it make sense, guys? So basically, we're just using additional methods to get this kind of sensitive information and to set it instead of like making it public and allow to manipulate it directly. But like in theory, you can still do that. You can like, you don't have to, you may not to specify that, you can make it like a public and access this wheel attribute directly from the class. But it just, I would say it's just the best practice to do that.
Yeah, in more modern languages, like for example, C#, there is a special property that kind of does it, but kind of a little bit nicer, but the same purpose, to add some extra logic if needed. In Java, this is a very like classic way of setting and getting the values. You can basically, what you can do here, you can actually call like right after, let's say, set wheels, you can call print me method, right? Which is private. You cannot really call it from the outside, but you can call it from the set wheels, right? Can you do that?
Mm-hmm.
You know, and you can say like, I don't know, how the truck has like, and then wheels.
space and wheels.
Because you see, it's private, you can actually call it from the class itself, but not from the outside. And print me, you cannot call it because it's private again. However, you can, when you set it, you can actually call that. So if we run it, this code right now, we will see that that print method is being called actually.
Yep.
You see, guys, and right after we assign that. So
yeah, and here is a logic.
You see, wheels is purple, so it's not those white wheels, but those that are purple ones. Private line number 4 or 5. Sorry. Is it clear, guys?
So basically, here we're like setting the number of wheels, like in the line number 8, and then like we're using a print me method where we're like not hard coding how many wheels it has. So we're dynamically passing these wheels after we're like setting it, like right after. And that's why it's like printing it here.
Any questions, guys?
Okay. If you guys don't have any questions, we will cover to another part, which is called like polymorphism. So what the polymorphism means? Basically, let's say sometimes like after we inherit method, and these like methods, they can use kind of I mean, they can use like the same methods, but they can like perform the different task, right? I mean, let's say like in our example, like in a car, and we have like a Mercedes class, which is inherited from it. But let's say if you will have here, let's say print me method, right? And let's change it a little bit. And let's say like I am car class. So in a Mercedes, we can actually use the same method, right? But because it's not the car class, it's basically, yeah, here's a typo. We can name it, I'm a Mercedes. I'm a Mercedes class. And let's say, let's actually create another class. So you will like, so hopefully it will help you to get an idea. BMW, and let's also inherit in the car class. And let's copy this same method here. Yeah, so the idea here is like it's the same class, right? But because like BMW and Mercedes, they are two different models, they can still like use kind of the same name for a method, but they will do like different things with that. So like, let's say like Mercedes class will, once you will call this print me method, it will like print like I'm Mercedes. BMW, like if we will call the BMW class, it will basically print this text here. Let me actually call it from here, so you will like get an idea. So Mercedes, BMW. And let's call the print me method within the oh, it's a private. Okay, let's change it to the public for this example. The same here. All right, and so let's run this program. And as you guys can see here, it will print completely different things, even though they still calling the same method names. So in OOP, it's called polymorphism, which is basically the way that allows to implement, like to perform different things within the same like methods or attributes.
Azad, can you open, please, car tab?
Yeah. So yeah, you guys see it also has a print me method, right? But what's happening is like it's inherit from here, and it's actually override what it has, like this one.
Do we have to type system out print line in car tab, in car class? Because if it's overwritten anyway.
No, you don't have to. You can just comment it out. And because it's overridden, and it will still work. Yeah, it's fully overridden. I can like even like delete it. It will be like the same thing.
Well, the trick here is that for some cars, for example, you don't even need to override it. It can be just fine. So you just don't do anything, and you inherit that method from the parent class, from the super class, and it's gonna work. So even though in a class, maybe can you maybe do we have like a I'm a known car, right?
Yeah.
So for example, in BMW, if we don't have that method, let's say, like completely, we can just delete it, or it's not there, but we still can call it, right? The parent class will be called. Oh yeah, it's private, that's why. So if you run it now, even though BMW doesn't have that, you see, it calls the parent print me method, which is I am unknown car. Make sense?
Absolutely.
Nice. Yeah, so basically this is an idea of polymorphism. And I believe, yeah, this is like another example of the polymorphism implementation. And I mean, as you can see here, like in this like simple example, it's the same idea. So we have a parent class, which is superclass animal, and it just like has some generic string to print. And we also have a pig and a dog classes, which is subclasses from the animal class. And here we are basically specifying like what's the animal sound for the specific animal. Yeah, I mean the same idea, the same logic here. Yeah, and so we already covered 3 topics, and this is number 4. It's called abstraction. So it's actually a really huge topic about abstraction, and there's a lot of ways in implementation how you can implement it in Java. But in a simple words, the idea behind the abstraction, it's that you sometimes in most cases you don't necessarily need to know the logic of the methods itself, right? Or the logic about the class itself. So you will just need to know like a final result that you're gonna get. Like let's say let's say even like here. I mean, in simple example, just a system out println, right? Like we don't know what the system is, right? We don't know like what's the class of that, and we don't know what's the out and what's the println. Like all we know is that this kind of method, it will just print us something. And this is kind of like end result. And we don't dig deeper to the details about how it's actually implemented. And the idea of abstraction is like exactly on that. So you're like more trying to specify on the end result rather than in digging like a deeper to the implementation level and how it's all like implemented.
Yeah, so I would say here, just talking like not computer science terms, but just regular. We actually, as a human beings, we use it a lot every day. So let's say if someone asks you like, how long did it take you to get here to the work, let's say, or to the class, whatever, right? You just basically give like number like 1 hour, let's say, right? That's it. And this is really very abstracted way. So you just really give a detail, just information, like 1 hour. You never say like, oh, I don't know, I started at 6 p.m. and then I made a right in 3 minutes, and then I make left in like 5 minutes, and then straight ahead for another 15 minutes and stuff like that, right? You just give a number, that's it. No details, because these details are irrelevant. You getting the idea?
Yes, thank you.
Yes.
So here the same thing, system out, println. It can be something else, but who cares? Like you really care about like printing this thing to the console, nothing else. You don't care how it's how to actually print it.
Yeah.
Right. That method knows how to print it, but for you, you don't have to know that. You just have to know which method does it for you, right?
Yeah, it's kind of like higher level of implementation, right? And so basically, I mean, the same idea, if you will have like a standalone application, like which has UI, you will just click to the buttons and you will get like expected results that you're expecting. But let's say you won't have access to the code itself, and like you don't need necessarily to know that.
So another example would be, could you maybe, as that, it's a good question how to do it, but if we could trigger some runtime error exception, that would actually show us the whole stack trace. And stack trace is nothing but all the abstraction layers involved. And I believe in average Java application, I heard something about like 70 abstraction layers being called just for that error. Like whatever error really is, it doesn't matter.
Okay, we can use the loops probably for it. Let's say integer e equal to 5, and
oh, you can actually basically just throw new exception. Let's say, I don't know, throw new like null pointer exception maybe without actually doing anything. Let's see how it goes. Null pointer, yeah, it's right there. Yeah, basically that's it. But let's try this one. Not much, huh?
Yeah.
Yeah, okay.
Yeah, if we will have like more complicated architecture of our program, it will just show you like a whole stack trace. I mean, we actually can probably
You can just Google it actually, right?
Yeah.
So the way it works really, so let's say you work with Selenium WebDriver, and then you're looking for some element on the page, but that element, yeah, this is how it looks really. Number format exception. So basically it expects some special format to parse, but it cannot. So as you can see, there is a whole bunch of abstraction layers involved. So basically the top level is actual issue. It cannot parse. So it threw wrong format exception because it couldn't parse it. Basically, it was not a number, but let's say string. So it couldn't parse it really.
Yeah.
But why it happened? Because the next layer, you see, there was some admin user policy edit helper. I didn't even know what it is. That one was called, and then another one, consumer policy class was called, and then another one, mobile option screen, and then another one, servlet dispatch event, and then do post, and then HTTP. So it goes actually all the way to like very, very low level thing that usually we don't even work on those levels. We don't even know how they work. The good thing here that we don't have to. That's the whole beauty of abstraction. Again, all that you need to do is just parse integer. How it parses the integer, none of your business really. We don't care. But if something happens like this, you will see the whole stack trace going to, you see thread run, which is basically like main method or something. So it will go all the way, call all those classes that being involved in the process. But for us, we usually only take a look at like first, like a couple of first lines. We don't go usually that deep because it's becoming very technical down there.
Yeah. But sometimes it's hard to identify a problem in a like higher level. Sometimes the issue may be like, I mean, I don't know, kind of like admin controller, maybe the bug there, right? But you will see the parser error here, but the error may be like somewhere here. And just to keep like, you know, do some investigation and you will need to find.
Yeah, so hopefully guys, it makes sense. We will see it a lot in the future, and if you don't get it right now, that's fine. That's a kind of advanced topic, but again, all these concepts are being used widely in the programming and the test automation as well, and we will see them a lot. And
Yeah.
so if you don't get it now, you will get it later on. That's fine. Don't be scared.
Yeah, so first thing is like we will actually use them in the future in our course. And the second thing is like you may be asked these questions like what's the abstraction in the Java, or like what's the encapsulation, and how does it like look like in simple words?
Yeah, it's actually a very popular question about object-oriented programming concepts. So you're supposed to, they can ask you like what concepts do you know, and you basically have to throw them all in, at least to be able to say a couple of words for each concept, which is really hard to do if you don't know what it is. If you don't understand it.
Yeah, even like in the simple words, like if they ask you what's the encapsulation, you can just say it is the way to restrict the data, and there's like a 3 type of access level. It's public, private, and protected. And that's basically what they wanted to know. They want to see like how you, like if you understand the full idea and the full like power of OOP.
Yeah, again, why it's important, because every single field or method actually has that. Even like public static void main method has that. You cannot create a method without really setting that thing.
Yep, exactly. All right, guys, so we don't have much time for exercises, but don't worry about that. We will do more exercises in a Saturday. just to, you know, like close this topic and to move on. So I'll prepare kind of exercises for Saturday. So for today, do you guys have any like other questions before we will finish?
Yeah, Dennis, will we use in the future classes such exercise? Will we do such exercises like on the first classes, sort of mathematical? Because I didn't get it well enough.
Yeah, so yeah, it's quite a few of them really, and we're gonna do some of them. We're gonna
Or
keep doing them.
Maybe it's not necessary at all.
No, I mean those are very popular interview questions. Unfortunately, if you fail that one, you basically don't have any chance to to get through.
It's a pity.
Because well, the good part is sometimes they ask you like some basic sorting, and that one is pretty easy, but it's gonna take you like half an hour maybe, or even an hour, like talking about stuff, which is, if you at least understand how it should be done, then you're good. But if you fail that one, basically, I would say you have no chances to get through.
Okay.
Yeah.
Yeah, we have like fuzzbuzz, like Fibonacci, like sorting. Bubble sorting is kind of still popular for whatever reason.
Palindrome.
Yeah, all of those things. Yeah. I mean, some of them are very tricky, but we're not going to be doing anything crazy.
Yeah.
That's the next course.
Yeah, and I have a question about encapsulation. Yeah, if we, for example, have two classes and both classes have their own methods, public methods, can both of those methods have the same names or not?
Yeah, it's like it's idea of polymorphism, right? When like
about polymorphism, right?
Yeah, it's not encapsulation really.
Yeah, it's basically when two different classes have the same methods, but the implementation of these methods is different.
Yeah, since those classes have since those classes are different classes, they can have anything that they need. They don't have to match exactly. They don't have to be even similar to each other, right?
Yeah.
So, and we will call these methods differently, right? Because we have the same names.
Yeah, but you will need to initiate the classes as an object, right? And only call it within this particular object.
Yeah, I got it.
So yeah, the idea here, whatever we're doing, we are always, it's all about objects, right? So you need some object, the particular object, and then you can call some methods within that object. So cars can like, can drive, let's say, right? Or can honk, or can stop, or can turn left, turn right, those kind of things. So you always go like Mercedes car dot like honk. So you always have to have a reference of the object.
Yeah, I got it. Thank you.
So that's why it's called object-oriented programming. It's all about objects.
Any other questions, guys?
Yes, I have a question. Can you give us an example how we're going to use polymorphism concept in automation?
So in the examples that Dennis mentioned about the page object model, I mean, let's say in this, like we will talk about more in the future, but let's say we will basically just separate the screens, and we will specify specific methods that's relevant to the screens. Like let's say like home screen, or like a user profile screen, or like a search screen. And like within these classes for different pages, we can get like some common method names, like verify, like get page title, right? And for like all of these pages, page title will be different. And this is kind of like example of polymorphisms that's come to my mind.
Or we can use like navigation things.
Yeah,
as well.
navigation is another one. So usually
Okay.
there is like a base. So for example, there is a base URL. Let's say for Google, it's going to be like google.com. But then let's say for create account on google.com, it's going to be google.com/create account, right? So you can actually directly jump to that page. You don't have to go through the home page and then find some element over there and click to get to login or create account page. So you can actually have let's say go-to method on the home page and for the home page and for create account page. So it's going to be the same exact method. And basically depends on the object, it will call the different URL. So it will be google.com like create account or google.com nothing really. That's it. For home page is really empty, nothing else, right?
Yes, okay, thank you. I got it.
Yep.
Mm-hmm. All right. Any other question, guys? Okay. Okay, I will take it as a no. Again, like this Saturday, we will do like more exercises, like class-related things. And yeah, and we will like class this topic about OOP in Java, and we're gonna use it later on in our real project, and you will see the real implementation of like basically of everything that we were talking about today.
Azat, I have a last quick question. Could you please add simple tasks till Saturday for homework, just related to our today's topics?
Yeah,
just
but
if somebody wish to do it.
yeah, sure, but it will be in the next week because we already have a homework that you need to finish.
Yeah, okay.
I don't want you to like overload.
Okay, thank you.
All right. Okay, thank you guys for joining us today, and we will see you on Saturday on the on-site or online.
Thank you.
Thank you. Have a good night.
Good night.
Thank you.
Bye.